Next topic is the basic energy consideration. So we use this equation to explain the V is the relative, V is the absolute velocity, flow velocity, and W is the relative velocity seen by the person riding on the fan blade. Okay, and U is the blade velocity. We can find from the angular velocity of the blade times the radius. Okay, so we got the U. Okay, and if we look at the next figure about the fan. Okay, this is a fan, and for the shade area is A, B, C, D. We move to the below A, B, C, D expand of the shade surface is a part of the cylinder surface. Assume that flow move around the blade from point 1 to point 2. So flow is move point 1 to point 2, this point. Okay, so at point 1 the fluid air enter and leave the fan at the same distance from the axis. So in this case we assume that U1 equal to U2 because it's the same radius. Okay. And entering and leaving contains U1 and U2 are not necessary, but the air leaving and entering and leaving are not necessarily tangent to the blade. So we construct the velocity triangle. In this case, there is the U1 on this because of the blade motion is moving up. So for U1 is moving up. Okay, and U1 is direction along the blade angle. So then V1 is perpendicular to the inlet surface. Okay, that is the velocity vector. And for the outflow at this point, for the out, U1 is still the same direction, is upward. Okay, and U2 is along the blade angle. So we can write the direction of U2. So in this case, U2 is on this direction is flow out. So it means the direction of V1 and V2 is not the same. In this case, the bridge push the fluid and causing its turn to change direction. Okay. And absolute velocity vector V is a turn during it flow across the blade. Okay. In this case, the conclusion, the bridge push on the fluid tangent component, so we call the pump. Okay. The next case is about the windmill, and we show you what this look like in the clips. That is small windmill. In this case, the air push the blade. Okay, that is so you can see common windmill in countryside. It's a multi-blade windmill. Another case is three-blade windmill. You can look at many places in Thailand for the power electrical generation on Khao Yai Thiang, and many places in CQ, Kun Thot. Okay. Okay, you can see what is the windmill look like. Okay, for windmill shown in below figure, the blades move in the direction of the lift force exerts on each blade on the wind blowing through the rotor. Okay, and you can see that that is the flow of air on this direction. So this is the V1. Okay, In this case, they push the air push the blade moving on this direction. In this case, U1 is moving down and U2 is moving down. U1 and U2 is the blade velocity, okay, and for the B1 is the relative velocity. It depends on the blade angle, okay, that is the B1. So in this case, you can see that the direction of V1 and V2 is changed, okay. And come to the conclusion that the fluid must have the push on the blade in direction of the motion. So in this case, we extract of energy from the fluid. So in this case, we classify two of the turbine.